Hi everyone, myself Dr. DHANALAKSHMI, Assistant Professor, Department of Computer Science and Engineering from BMSIT and M. So today I am going to explain the concepts of graph theory. Before getting into the concept, let me know what is graph theory and what are the basic terminologies are used for the graph theories. For example, now in a graph we have n numbers of vertices and n number of edges. So how do we find a solution using these number of vertices and edges? For example, now I have 4 cities. For example, let me consider there are 4 cities. One is New York, one is Coinsburg, and one is USA, and one more city called C. So now we want to traverse in a city without tracing twice the edges. Means all the vertices and the edges has to traverse only once. So for that, how do we find a solution for this without traversing an edge twice? Only once it has to traverse all the edges. So for this problem, we are going to use the concepts of graph. So in this graph theory, first if you consider, we'll have vertices. All the point nodes, I can call it as an vertices. And all the edges, what we are connecting it from one vertices to the another vertices is called as edges. So all the edges, what we are connecting it from one vertices to the another vertices is called as edges. Number of vertices and number of edges, always it has to be denoted with capital V. That is what we call it as a set of vertices, where capital V is going to represent n number of vertex in it. The same way, even edges consist of set of edges, and E, it has number of edges in it. The set of vertices is denoted by capital E, and the elements inside the set of each edge is represented with a smaller e. So number of edges and number of vertices are fine with it. Now the graph, how we are going to represent is like, so G consists of number of vertices and number of edges. So graph can be represented using number of vertices and number of edges. So the problem for this can be given, the solution can be given using the concept of graph. Now the graphs which consist of vertices and edges. So now let me see how the graphs can be using the directions, using the arrow marks, or without using the arrow marks, how it is going to represent the order pairs. So if I consider this number of vertices, now in this graph V and E. So for this graph, if I consider, the number of vertices can be V is equal to a terminal A, B, C, D. The edges can be A, B, or B, A, or it can be C, A, or A, C, and it can be D, C, or C to D. It can have edges. Why? Because we have not provided the directions for this diagram. We have not given a direction for this graph. So you can have an edge from A to B as well as from B to A. And we can have an edge from A to C and we can have an edge from C to A. And the same way we can have from C to D and even we can have it from D to C. So how many edges? For example, in this we have vertices are 4 vertices and here the edges are 1, 2, 3, 4, 5, 6. So E is 6. We have 6 edges and 4 vertices. For the same representation of a graph, if I mark it an arrow mark to it like this, how many edges and how many vertices are there? I can make it see here. For the same graph, this is for undirected graph. This is for directed graph. Now I have represented an arrow marks here. So now if I consider this, the vertices remain same. A, B, C, D. But the edges are, we have A to B because it is moving. The arrow marks what it is moving towards the B, means it is passing from A to B. So I can have an edge only from A to B. So my edge will be A to B. The next, if you look into it, we have an edge from A to C. So from which vertex it is moving to which vertex? From C vertex it is moving to A vertex. So it means that I can have only an edge from C to A. So here I can write and C to A. The next is, here the arrow mark is representing from C to D. So it is moving from C vertex to D vertex. So I can say it as C to D. So how many vertices are in, how many edges are represented in this graph, in directed graph? It is 3. So my graph consists of 4 vertices and 3 edges. See here, the same thing for undirected graph, it is 6 edges and number of vertices are 4. With the directed graph, the number of vertices are 4 and the number of edges are 3. So I can say that this edge, what we have got, is an unordered pair of edges. In this graph, directed graph, I can say it is an ordered pair of edges. Ordered pair of edges. So this is the difference between a directed graph and an undirected graph. Now, in any graph, if I consider it, I can say that which can be the start, because any graph, if I consider it, it should have an initial vertex as well as terminal vertex. So in this graph, if I consider it, A, B. In this graph, if I consider it, I can say that this vertex is always an initial vertex. This which is going to end is called as terminal vertex. From A to B, we have a connectivity. A and B are the edge. A and B are the vertices. A and B are vertices. And edges can be A, B. So A will be an initial vertex and B will be a terminal vertex. So now, after knowing the initial vertex and the terminal vertex, if an edge which starts at the same point and which ends at the same point, like this is a point A, only we have a single vertex, and here we have which is going to start with the same edge and it is going to end at the same vertex. is called as loop, which is called as loop. It's going to start at the same end, same initial vertex, and it ends at the same terminal vertex. So A is at both initial vertex as well as the terminal vertex. So I can call such type of vertices as a loop. And in a loop, I can have it like A to B with an arrow marks, and we have another vertex, that is B. So this is called as parallel edges. It is called as parallel edges. A is a vertex, B is a vertex with a direction. It says that from A to B, one edge we have. At the same point, we have one more edge. So I can say that these two edges are parallel to each other. Such things we call it as a parallel edges. The same way we can have multiple parallel edges, like we have a vertex A, and from there it goes to B, and we have one edge again, one edge from A to B and one more edge from A to B, and I can have still more edges. So this is what I call it as an multiple parallel edges. We call it as multiple parallel edges. I hope you all are clear with this. Terminal vertex, initial vertex, what is loop? In case if you are not providing a direction, like for example, it starts with A and we have a loop, this will be called as undirected loop. For the loop with extension, one more vertex is added with one more edge, then I call such graph as a parallel edge. And for the same parallel edge, if we have multiple edges, then I call that as a multiple parallel edges. Now we'll see a graph which is not connected to any of the edges. For example, if I consider V1, V2, V3, V4, V5, and we have one vertex is called as V6. Now, if you notice this graph, you can see that a vertex V6 is not connected to any of the edges or any of the vertices here. So, such graph, such point, I call it as an isolated vertex. I call it as isolated vertex. Why this is called as isolated vertex? Which is in a diagram, if I consider it, this point is not having an initial point or it does not connecting to any of the terminal points. Such vertex we call it as an isolated vertex. So this is isolated vertex. Now we have got to know what is isolated vertex. So non-isolated vertex means it is being connected to some edge or some vertex. So such thing, the non-isolated vertex, the non-isolated vertex, a non-isolated vertex which is not an terminal vertex, is called source. The same way, the non-isolated vertex non-isolated vertex, which is not a initial vertex, which is not a initial vertex, is called sink, which is called sink. So for this, I'll just show you an example how you can understand this graph. So in an we got to know what is isolated vertex. Now we'll see what is source and what is sink. So in a graph, if I consider, for example, if I consider this as a graph, I call it this as B, I call this as A, I call this as C, and I call this as D and E, and I have in it one more vertex, that is isolated vertex. We got to know, see, this will be your initial vertex, and this point I call it as a sink. What do you mean by sink? Sink means a non-isolated vertex which is not an initial vertex. So C is not an initial vertex. So B is the initial vertex. So I can call the point C, that is the vertex C, is a sink, because it is not an initial vertex and it is not an isolated vertex of any diagram. The same way, in a source, if I consider, source means it is a non-isolated vertex which is not a terminal vertex. Okay, which is not a terminal vertex. So in this graph, if I consider, A and A to B will be your source. So sources can be A to B because it is not any terminal vertex. So the same way sink can be the point C is your sink. The point F is an isolated vertex. So this isolated vertex is F. So this is how the basic terminologies of graph is being used. We should know, when we are knowing what is graph theory, when we are learning what is graph theory, we should know what is undirected graph, what is directed graph, and what is isolated vertex, how the loops is been written, and what is parallel edges, and what is multiple edges, and what is source, and what is sink. So if we know all these, the basic terminologies, then for us it will be very useful for us to draw a graph. So graph theory, you all might be thinking why the graph is needed, what is the importance of graph, why we have to draw a graph for any of the problems. So let me see what are the problems are there and how we are going to provide a solution using a graph. So for example, if I take it, in today's trend roads, if we consider it, if you want to build in a smart cities, so how you are going to build in a smart cities? You have to find out first all the paths which is being connected. So for that, we are going to find without any congestion or any traffic, we have to pass it in an easier way. So that is one of the most problem in the city. So we'll see how we are going to provide in a solution for that. And if I want to find the shortest path, so your GPS, if you consider it, it's going to provide you in a shortest path. So this shortest path, how I am going to provide a solution using the graph. And now if I want to cross from one bridge to the another bridge over many cities, so how we are going to provide, this is what we call it as a traversal problem. So for this all problems, we have a solution. The problems for the real time, we can provide a solution using a graph. Just a simple example, how a solution can be given to a graph. For example, I have a point. I have a point just like this. I am moving it from one place to another. Okay. So these are the cities A, B, C, D. So how I am providing a solution without tracing this? tracing twice. Without tracing twice, how I am going to provide a solution. So in a graph, we can consider these points as vertex. So I call this as V1, and from here to here I call it as V2, and from here to here V3 and V4, V5, to V3, and I can provide a solution from here. So these are the vertices. I am going to convert the problem into a solution using the concept of graph. So here these are called as vertices, and now I am going to represent these vertices as E1, E2, E3, E4, E5, E6, E7, E8. So now I calculate which has the shortest path. Just like the wait 2 minutes from V1 to V2, and for all the things just I'll give it 4, 5, 3, 2, 4, 5, 8. So now I want to know from A to V1 to V4. So which path I am going to choose? We have a path from V1 to V2, V2 to V4. And we have a path from V1 to V5, V5 to V3 and V3 to V4. And we have a path from V1 to V2, V2 to V5 and V5 to V3 and V3 to V4. So in so many ways we can traverse. But which has the shortest path? So for that I am going to consider V1 to V2, V2 to V3. So what is the minutes it's going to consider? 2 plus 2 is equal to 4. So this is how your graph is going to help you to find out a solution for the shortest path. So the same way for most of the problems in computer science engineering, if you consider it, we have so many real-time problems are solved using the concept of discrete mathematics structure. You consider it AI, ML, we require DMS. You take it cryptography, we require discrete mathematics structure. And if you consider it for all the networking, how the cables have been distributed, how it has to be checked with the loads and all, we want the concept of discrete mathematics structure. So all these things, for all the problems, we can get a solution using the concept of DMS. And in the DMS, we have a concept of graph. So this graph theory is going to help us to provide solutions for many real-time problems. Okay, students, for now, we'll stop here till the graph, the basic concepts of graph, and we'll see the things in the next upcoming videos. Thank you so much.